Es un grato placer darles la bienvenida a nuestra ciudad, Guayaquil, nuestro país, Ecuador. Gracias a todos por estar acá, esperando que su estadía sea placentera. Para la Escuela Superior Politécnica Litoral es un honor darles una calurosa bienvenida a esta primera conferencia internacional de la Sociedad Panamericana de Métodos de Modelado, Ingeniería y Ciencias Aplicadas, PANASOMM 2022. Vamos entonces a empezar este evento con las palabras de bienvenida de la doctora Gloria Gallardo. Ella es directora de Turismo y Promoción Cívica de la muy ilustre Municipalidad de Guayaquil, quien hoy a través de este video va a extender un saludo a los visitantes y asistentes de este congreso.
Buenos días, miembros de la mesa directiva y asistentes a la primera Conferencia Internacional de la Sociedad Panamericana de Métodos Numéricos en Ingeniería y Ciencias Aplicadas, PANASOMM, por sus siglas en inglés. Es un honor para nosotros contar con la valiosa presencia de ustedes en nuestra hermosa Guayaquil, ciudad académica, capital económica del Ecuador, puerto de la patria y puerta de entrada a las Islas Galápagos. Desde el año 2014, que fui nombrada por el exalcalde de Guayaquil, abogado Jaime Nebot, directora de turismo y luego representante de él como presidenta de la empresa pública municipal de turismo, promoción cívica y relaciones internacionales, mi objetivo prioritario siempre fue lograr que Guayaquil cuente con su propio buró de convenciones y visitantes. Era la única forma de ir posicionando a nuestra ciudad como el destino preferido de la industria de reuniones, ferias, congresos y convenciones a nivel regional y mundial, porque Guayaquil, siendo una ciudad comercial y de negocios, siempre contó con toda la infraestructura hotelera de las principales cadenas internacionales de hoteles de 5 estrellas del mundo, con los servicios de primera calidad en toda la cadena de valor de la industria maíz y la completa infraestructura turística que le permitía competir con cualquier destino del mundo en todo lo referente a la realización de eventos internacionales. Claros, con este objetivo, en el año 2014, mediante ordenanza municipal, la alcaldía de Jaime Nebot del Consejo de Guayaquil creó la empresa pública municipal de turismo, promoción cívica y relaciones internacionales, conjuntamente con el Buró de Convenciones y Visitantes de Guayaquil, cumpliendo yo así esta aspiración para empezar a trabajar juntos con el sector privado y la academia en convertir a Guayaquil en un destino de reuniones. Me llena de orgullo saber que hoy en día, gracias a nuestro esfuerzo y perseverancia, Guayaquil cuenta con un buró de convenciones y visitantes que presido, conformado por un gran equipo de profesionales que han logrado posicionar a nuestra ciudad como el destino líder de reuniones en excelencia en todo el Ecuador y un destino preferido de la industria maíz en la región y el mundo. Estamos afiliados a la ICA, la Asociación de Congresos y Convenciones Internacional más importante a nivel mundial. En el año 2018 creamos y lanzamos el programa de embajadores de Guayaquil, que lo integran los más altos representantes de los gremios profesionales, asociaciones, cámaras de la producción y la academia, quienes han sido y continúan siendo los principales protagonistas de las postulaciones de congresos y reuniones para la ciudad. Ustedes son parte de este selecto programa de embajadores, a través de la doctora Cecilia Paredes, rectora de la Escuela Superior Politécnica del Litoral SPOL, y el doctor Clotario Tapia, miembros del comité organizador de este evento, PANASOMM 2022. Sin lugar a dudas, la industria de reuniones, ferias, congresos y convenciones es el segmento especializado que más rápido se está recuperando en todo el mundo. Es el que más gasta, el que impulsa el turismo de ocio y principalmente aporta un invalorable intercambio de conocimientos científicos, culturales, académicos para la sociedad. Esta importante reactivación y valioso desarrollo de la industria maíz en la ciudad de Guayaquil se refleja con la planificación y ejecución de 60 eventos internacionales para el presente año 2022. La realización de los 60 eventos significa para Guayaquil un gran impacto económico que generará una derrama económica de $374.890.800 que se traducen en 237.700 noches de alojamiento en establecimientos hoteleros y la visita de 92.792 turistas a la ciudad, lo que constituye un beneficio de progreso y bienestar para la ciudad y nuestros conciudadanos, considerando que el turismo es el mayor generador de empleo y de riqueza nacional. Ustedes tendrán la gran oportunidad de conocer a Guayaquil, una ciudad mágica, acogedora, de gente hospitalaria, alegre y emprendedora, características del guayaquileño que con trabajo y esfuerzo ha logrado que Guayaquil brille como la perla del Pacífico, también del turismo. Guayaquil se luce por su naturaleza, por sus orquídeas, por sus manglares delfines, sus bellos malecones, sus bosques secos tropicales, todos al pie del río y del estero, su deliciosa gastronomía. Es una ciudad digital, con internet gratuito por 45 minutos. Su aeropuerto internacional José Joaquín de Olmedo está catalogado como uno de los mejores en su categoría en el mundo y está ubicado cerca de las más grandes cadenas internacionales hoteleras que están en Guayaquil. Bienvenidos a Guayaquil. Gracias nuevamente por estar en mi hermosa ciudad. Los recibimos con los brazos abiertos y estoy segura que volverán porque se van a enamorar de Guayaquil. Les deseo mucha felicidad y éxitos en el desarrollo del evento PANASOMM 2022. Felicitaciones a ustedes, que son los protagonistas de este evento.
Demos un aplauso a esas palabras calurosas de bienvenida de parte de la doctora Gloria Gallardo, en representación de la muy ilustre Municipalidad de Guayaquil, a quien agradecemos también el apoyo brindado para esta conferencia. Ahora quisiera invitar al decano de la Facultad de Ingeniería en Mecánica y Ciencias de la Producción de SPOL. Él es el doctor Ángel Ramírez, quien en representación de SPOL les dará también sus palabras en esta mañana.
Thank you. Good morning, everyone. Dr. Eduardo Divo, Senior Associate Dean of the College of Engineering of the Embry-Riddle Aeronautical University, Professor Diego Ortiz, Academic Coordinator of University Técnica del Norte, members of the organizing committee, respected keynote speakers, dear researchers and representatives of the academic sector who are with us today. On behalf of our President, Dr. Cecilia Paredes, I am very pleased to extend a cordial welcome to the first meeting of the Pan-American Society of Modeling Methods in Engineering and Applied Sciences, PANASOMM 2022, organized by SPOL, Politécnica University, the Universidad Técnica del Norte, and the Embry-Riddle Aeronautical University, in order to promote opportunities for collaboration between scientists in a wider Pan-American context. As SPOL, we reiterate our commitment to the scientific community to generate spaces in which a synergetic cooperation between institutions can be attained. It's a pleasure for us to have you all here on our campus hosting this conference, focusing on experimental and computational modeling in transversal subjects such as biomechanics, materials, energy, structural design, robotics, aerospace, to name a few. Undoubtedly, this enrichment multidisciplinary experience will enhance the cooperation between our institutions and, therefore, will set a start for a thorough networking that leads to further understanding and professional training to the scientific community. We thank the academic institutions, research centers, and organizations that have joined this endeavor. We hope that each year this event gets more attention and more institutions continue this initiative that allows everyone to share our scientific contribution to the society at large. I must address my gratitude to the Ecuadorian Corporation for the Development of Research and Academia, CEDIA, and to the Public Company for Tourism, Civic Promotion, and International Relationships of Guayaquil for the support to this event. On behalf of our President, Cecilia Paredes, she sends her apologies to not being able to be here, and we welcome everyone to PANASOMM 2022. We really hope you enjoy the prepared agenda and get the best out of it. Good afternoon, everyone.
Gracias, doctor Ramírez, por sus palabras. Para SPOL es importante seguir fortaleciendo estos lazos internacionales para el desarrollo de proyectos colaborativos y expandir el campo de la investigación. A continuación, damos la palabra al doctor Eduardo Divo. Él es decano asociado del Colegio de Ingeniería de la Universidad Embry-Rice. Bienvenido.
Buenos días. Eduardo Divo es mi nombre. Voy a tratar de simultáneamente hablar en 2 idiomas, a ver si lo puedo hacer y comprimir mi presentación de hoy, el tiempo que se me ha asignado. Pero lo primero que quería hacer, so I'm going to try to speak in 2 languages simultaneously, if that's not a challenge. I don't know what is it. But the first thing I want to do, lo primero que quiero hacer es agradecer a todo el staff, a la maestra de ceremonia, a los organizadores técnicos allá en el cuartito por tomar tiempo de su domingo y de sus familias por estar aquí a las 10 de la mañana ofreciéndonos esta calurosa bienvenida y este muy bonito reconocimiento y está muy bien organizado este evento hoy en la mañana. También quiero felicitarlo por su campus. Nunca había estado en Guayaquil, nunca había estado en su universidad y el campus es precioso, es enorme, está metido en un ecosistema muy bonito y la verdad que me impresionó solo de manejar por aquí. So I just want to thank all the staff here for taking time out of their precious Sunday and from their families to be here and congratulate them for such a beautiful city and such a beautiful campus. It's a great, very large campus. Muchas gracias por su hospitalidad también. Desde que llegamos a Guayaquil hace 2 noches, todo ha sido maravilloso. Desde que aterrizamos, llegamos al hotel, la organización de la parte histórica de la ciudad. Tuvimos la oportunidad de probar la gastronomía local, increíble. Y bueno, muchísimas gracias por todo eso. On behalf of the organizing committee of PANASOMM, I want to welcome you to the first international conference of the Pan-American Society of Modeling Methods in Engineering and Applied Sciences. I hope this is the first of many. I don't know what the cadence of this conference is going to be yet. This is all to be decided. We have a mission and a vision statement for our society. We have an idea of what we want to do, and we took the opportunity to do this first event, and we thought it would be very appropriate to do it here in Ecuador, to do it in Guayaquil, and then tomorrow starting in Galapagos Island. So this is the organizing institutions, or the sponsoring institutions. I myself come from the Embry-Riddle Aeronautical University. Our main campus is in Daytona Beach, Florida, and it's a university that, given its name, it focuses on aerospace and aviation education. But we have a large campus and a large faculty of engineering, or college of engineering, that has all the typical disciplines, such as mechanical, electrical, computer, and so on. We also offer all the gamut of different engineering programs from bachelor's, master's, and PhD. ESPOL, Escuela Superior Politécnica del Litoral, thank you for also being one of the sponsors of this event and also for hosting us today in this part of the event in Guayaquil. And I'm going to introduce all the organizing committee one by one. And also the Universidad Técnica del Norte, UTN, and Ibarra, Ecuador, also one of the organizing and sponsoring institutions, among with the 3 members who are here from the organizing committee. I also want to thank you for your sponsorship. So the background is PANASOMM is a society created to promote research and collaboration among researchers and institutions from the Pan-American scientific community. The first of these events, the first international meeting of the society, will take place in Guayaquil and the Galapagos Islands here in Ecuador from May 22nd to May 25, 2022. We have been meeting for almost a year between us, the organizing committee, and the original plan was to wait a little bit longer, but we thought it was appropriate with the end of the pandemic or with the relaxation of some of the rules in the pandemic. We thought it would be appropriate to meet soon, 2022. I think we're all tired of not being able to go and meet our colleagues in scientific events and forums. For the last 2 years, we have been doing this hybrid or online, and we miss a lot. I think a lot of it is actually missed when you cannot meet in person. The personal collaboration or the personal interchange is essential for scientific growth. So that's what we accelerated the organization of this event to 2022. So it took us, it was a lot of work, especially from the local organizers, who I'll introduce in a minute, but we pulled through. So why Guayaquil? And I'm sorry, I apologize if I don't make honor to all the Guayaquil represents, but this is what we've listed in our website. Guayaquil, the city of the river and the estuary, has become the principal gateway to Ecuador due to its connectivity, excellent weather all year round, and its attractive and diverse tourist offer. With its beautiful sidewalks and beautiful landscape and incredible nature, continues to incorporate more spaces dedicated to history, culture, entertainment, and gastronomy. The National Cocoa Museum has just been inaugurated. The iconic Panama Street, with cocoa was dried, is today one of the favorite places of locals and foreigners. Guayaquil has everything to live the greatest experiences, an open city to explore it, to enjoy it, to discover all its times, at all times, having our best characteristics, the joy, the warmth, and the hospitality of our people. And trust me, we've experienced this on the few hours or the last couple of days that we've been here. And then why the Galapagos Islands? Well, these islands are located about 1,000 kilometers to the west of the Ecuadorian mainland on the Pacific Ocean. This Ecuadorian archipelago is strategically located at the convergence points of three main oceanic currents: the Panama Current that flows from the north, the Humboldt Current that flows from the south, and the Cromwell Current that flows from the west. The nutrients brought to Galapagos by these currents throughout the year make its waters one of the most diverse marine ecosystems on the planet. Additionally, Galapagos' geographical isolation has allowed the relative small number of species that managed to colonize to the islands to flourish, resulting in unprecedented levels of endemism. It is precisely the observation of Galapagos' unique fauna that led British scientist Charles Darwin to publish his book on the origin of species by means of natural selection in 1859. In this book, Darwin probed the evolutionary theory, shifting the human understanding of the natural world forever. So we are paying homage to this scientific discovery that basically changed everything. So here's the organizing committee. Myself, Eduardo Divo, I am a professor, as it was mentioned, Senior Associate Dean of the College of Engineering at Embry-Riddle Aeronautical University. Victor Guayamabe, who's actually from the city, originally from the city of Guayaquil, and he's a faculty member too at the university, and Embry-Riddle Aeronautical University, is here with us. Briseida Gámez, who's also a professor at UTN, Universidad Técnica del Norte, and David Ojeda, also a professor at UTN, Universidad Técnica del Norte. They're part of the local organizing committee, and we have a long-standing relation. David, Briseida, and I have collaborated multiple times over the years, and I think we started working maybe 17 years ago, and some of what we've done is organize some of these events and actually led through a lot of scientific collaboration and put a lot of people together. So they are here in Ecuador, they're local, they're not in the city of Guayaquil, and I thought we invited them to be part of the organizing committee, and I thought it would be appropriate because they have a track record, a long history of successfully organizing events such as this. Diego Ortiz, also a professor at UTN here in Ecuador. He is here in the city right now. He should be here in a moment. And more importantly, Clotario Tapia, who's listed last but should be listed first. Clotario is the organizer, the person who made all this happen here in Guayaquil and also in the Galapagos Islands. He is the local organizing committee. He's a professor here at Escuela, and we thank Clotario. And I think he was one of the instigators of this idea. He's been planting this seed on Victor for a long time, and Victor has been telling me, I have a friend in Escuela who's who's trying to organize something where we can collaborate, we can actually network, we can create a society of scientific understanding and scientific collaboration. And so we started talking and said, well, let's start with an event. We have many successful models around the world, such as semantics or ecomass. These are models and European models where scientific collaboration for engineering and applied sciences. They meet on a very regular basis, and they have grown to be very large. And they have sort of subsidiaries here in Latin America. They support Latin American research, but it falls under the umbrella of ECOMAS. So we thought it would be appropriate to have our own society, our own locally grown and locally bred society, and that's what we call it PANASOMM, Pan-American Society of Modeling Methods in Engineering and Applied Sciences. So thank you, organizing committee, for making this happen in such a short time. We also are very fortunate to count with very prestigious keynote speakers, the lecturers who are going to be talking in the Galapagos Islands. We have 4 keynote lectures. One of them is, and we strategically selected these keynote lecturers so that they come from different parts, or actually diametrically distant or opposed parts of the Pan-American continent. So we have a person from Ecuador, a local person. We have a person from the United States. We have a person from Brazil, and we have a representative from Chile. So we have people from everywhere in the continent. First one is Victor Hidalgo, who's here with us, and Victor is from the EPN, Escuela, Politécnica Nacional in Quito, Ecuador. And I've had a chance to meet Victor in person during the trip, and we've actually met over Zoom a few times. And I've had a great pleasure meeting him, and we've had already a great time, and I know this relationship is going to go a lot further. I can see that. Dr. Alan Kassab is from the University of Central Florida, that's in Orlando, in the United States. The University of Central Florida, the second largest university in the United States. So it was actually the largest university in the United States up until 2 years ago. He is here also. We're very fortunate to have him to present some of his research work, a compendium of his research in biomedical engineering. Luis Robo, a person who I look up to very much so, such as Alan as well. Luis Robo is from PUC, the Pontifical University, Catholic University in Rio, in Brazil. Although he spent most of his career at Brunel in the United Kingdom, he recently moved back to Brazil just a couple years ago. And Luis is a world-renowned engineer and scientist with a long track record of publications and awards. And coincidentally, in a couple of days, he is going to be vested the Greens Medal. So this is a very big deal. And this is going to happen in an online event, because this conference was supposed to be in Estonia and Europe, but Estonia happens to be a little bit too close to some turmoil in that part of the world. So that has moved into an online event. So Luis is going to give his acceptance speech and to the Greens Medal from the Galapagos Islands. So it's going to be an incredible scientific achievement to be able to do this across the world and accept such a prestigious award. And finally, Eric Saavedra, who hasn't arrived yet, but he's going to join us in Galapagos. He's a professor at the University of Santiago in Chile, and also a very prestigious speaker with a long track record of research and modeling methods. So I want to also have the time to introduce my institution, Embry-Riddle Aeronautical University, and thank them for their support. Embry-Riddle Aeronautical University is a university that obviously focuses on aerospace and aviation, given its name, but it's a comprehensive university with colleges ranging from engineering and applied and arts and sciences. We have majors, the classical majors, and that you can find in all the universities. It's a quite large university with 5 campuses, one of which, the worldwide campus, is a campus that is comprised of about 150 mini campuses around the world. We have a large campus in Asia, in Singapore to be exact. We have a large campus in Prescott, Arizona, but the main campus and the largest one is in Daytona Beach, Florida, from where we work. In Daytona Beach, Florida, we're actually touching on about 8,000 students, but between all campuses, it's very close to about 30,000 students. And again, these are all full-time students, mostly full-time students, at least in the residential campuses, and we offer degrees ranging from associates, bachelor's, master's, and PhD. The university, and this is part of their website, or our website, has 9 top 10 rankings among its programs in US News and World Report. More importantly, or particularly, it's our space engineering program, and our College of Engineering in Daytona Beach is ranked number 4 in the world, or in the United States, by US News and World Report, among the likes of MIT, Stanford, Georgia Tech, and so on. The Daytona Beach campus has about 3,000 students in the College of Aviation, about 800 students in the College of Arts and Sciences, about 500 students in the College of Business, and about 3,500 students in the College of Engineering. And I've listed here a website that, if you have the time, go in. It's a virtual tour of the campus, and it's interactive and it's very nice. So it's uvisit.com/tour/EREU Daytona. So I have a video, a short video, to show you the type of things that we do. Shows some of the things that we do. I think I have another short video here to show specifically one of the aspects of the Eagle Flight Research Center.
Radical change is on the horizon. Soon, it will be overhead. The necessary technologies are proven. It's all coming together. At Embry-Riddle Aeronautical University, we're at the forefront of converging technologies. We're leading. We've been doing this work for years, and now we're taking off. Our mission is to transform human mobility. With the E-Spirit, we perfected the battery packs and the management systems to maximize utility. Motor controllers were developed for electric propulsion. A serial hybrid system was refined within our consortium. Pods with newly devised controls for transition dynamics were created, tested, refined, and commercialized. The sum of the parts is the revolution. Nothing stands in our way. Our personal air vehicle is coming. Climb aboard, sit back, you're about to arrive.
I'm sure this is making some of our students here very proud. I was also commissioned to give a small or short brief talk on, as a keynote talk on some of my research. I know I've been given a total of 45 minutes or so between my introduction of the conference, of the society. So I'm going to keep this very brief. This is it's technical in nature, but it's also a preamble of one of the keynote lectures that's to be given here in Galapagos in a couple of days. Dr. Alan Kassab, as you can read here, one of the co-authors of this study, is my close collaborator. We worked together for many years, since 28 years actually working together. And we are very fortunate to have actually joined forces with Dr. William DeCampley, William DeCampley is a cardiovascular surgeon, cardiothoracic surgeon. In particular, he's a pediatric cardiovascular surgeon. He operates on babies who have heart defects. And he specializes in all heart defects, but one in particular is the blue baby syndrome, what's called technically the hypoplastic left heart syndrome. It's a condition where babies are born with a single functioning ventricle. And just 40 years ago, none of these babies could survive. There was a 0% or zero chance of survival. And so there's a series of surgical interventions, surgical procedures that have been developed over the last 40 years to accomplish this, survival of babies. And he is one of only 70 surgeons in the United States who can perform these types of surgery. 3 surgical procedures in series from birth. From the moment a baby's born, you only have about 5 days to intervene. Up until the baby's about 2 years old, there's 3 open heart surgeries, very, very comprehensive surgeries. And he's a person also that understands engineering and science from the technical point of view very well, because he is trained as an astrophysicist. He has a PhD in astrophysics. So then he changed his career. I think he was bored, and one day decided to go to medical school, and then one day decided to specialize in cardiac surgery. So I think we've been working with them for about 10 years or more, and we've accomplished very great things. And this is something that gives us, because our group have been focusing on modeling methods, numerical simulations for many projects, ranging from aerospace to all other, or some other biomedical problems. But this one actually is very close to our heart, no pun intended, but it's very close to our heart because it gives us kind of a social purpose. This problem makes us feel that we're making a difference in somebody's life, literally. So we call this cardiovascular flow modeling, preoperative planning for congenital heart disease. And the other co-authors are, and this is also a compendium of many things that we've done over the years. And again, I'm just going to give an introduction as a preamble of what Dr. Kassab is going to talk to us in a couple of days. The other members of the group, Arkadas, or Dr. Arkadas, Dr. Ray Prather, Dr. Marwan Hamid. All 3 of them came from our group. They were PhD students at one point, and now they are postdocs or research scientists at different universities. Arka is in Embry-Riddle. He's the director of the cardiovascular research lab. Ray Prather is at the hospital with Dr. DeCampley, but he also spends time in our lab, and he also spends time in Dr. Kassab's lab at UCF. And Marwan Hamid, he graduated and then he went back to Qatar. He's a faculty of Bahrain, actually. He's a faculty member there. Michael Farias is also a cardiac surgeon. And he works at Arnold Palmer Hospital for Children. So let me show you where the team is located. This is a cardiovascular research team. This is the peninsula of Florida, the state of Florida, and southern part of the United States. You can see here is Embry-Riddle Aeronautical University in the East Coast, central East Coast of Florida. About 60 miles south of us is the UCF College of Engineering. 50 to 60 miles, is less than 100 kilometers from us, is the University of Central Florida College of Engineering and Computer Science. About another 30 miles below that, or south of that, southwest of that, is the College of Medicine from the University of Central Florida. And in downtown Orlando, right in the middle of Orlando, is Arnold Palmer Hospital for Children, where Dr. DeCampley works. So I have some pictures here to show you. This is the Embry-Riddle campus, and members of the team, such as myself, Arkadas, Ray Prather, and Marwan Hamid, have been part of the team from Embry-Riddle. This is part of the campus of the College of Engineering at UCF. This is one of the buildings, and Dr. Alan Kassab, who's a Pegasus professor. It's the highest honor a professor receives at the University of Central Florida in the Department of Mechanical and Aerospace Engineering. And Ray Prada, who also is a product of our team, he graduated, got his PhD a few years ago, and he's now a postdoctoral scholar at UCF. And Dr. William DeCampley, who happens to be also a professor of surgery at the College of Medicine of the University of Central Florida. And this is a picture of the College of Medicine, which is southwest of the campus where the College of Engineering is located. And this is the campus of the Arnold Palmer Hospital for Children in downtown Orlando. This is part of their building. There's a building that's for children, Arnold Palmer Hospital for Children. There's another campus or another facility that's for women. And there's a general hospital too, also named after him, after Arnold Palmer, which is a late golfer who devoted his time and his effort to setting up these kinds of ventures and hospitals to save children. So Dr. DeCampley works there. Michael Farias works there, also is a pediatric cardiologist. And Ray Prada also is a resident scientist over at Arnold Palmer Hospital. So what is hypoplastic left heart syndrome? El síndrome de corazón izquierdo hipoplástico, most commonly known as the blue baby syndrome or el síndrome del niño azul. It's basically, this is a normal anatomy and physiology of the circulation system where there is a left ventricle, a right ventricle, and the two have or form two separate parallel circulation systems. The red one actually feeding the systemic circulation, all the cells connected to all the tissue and throughout the body, including the upper circulation and the lower circulation. Upper circulation in humans is quite significant. About 25% of the blood that comes out of the heart ends up in your head. As mammals, we are by far the species that has the most percentage of blood going to the head, for obvious reasons. And then once the blood returns, after it has been basically supplying the entire body of oxygen and other nutrients, the blood comes deoxygenated and sort of contaminated with many things back to the right portion of the heart, which is in charge of sending the blood to the pulmonary circulation. And in the pulmonary circulation, the blood is going to exchange oxygen with the respiration system, and it's going to basically absorb oxygen and release CO2 and other things through the membranes of the alveoli, which are the ending membranes of the lungs. And this goes on and on forever, about 3 billion times in somebody's lifetime. This is a very reliable machine, the heart, and very efficient too, considering that it's only about a few watts every time it beats. So it's less power than a light bulb, and it's able to keep us alive. It's also very efficient because it only needs about 5% or less of the blood that it produces to feed itself, because the heart is a muscle. Now, about 1 in 3,700 babies in the United States, at least, are born with this condition called hypoplastic left heart syndrome, where the left ventricle, this one here, which is very powerful, the left ventricle is the most powerful of the two because it's in charge of sending blood to the entire body, so it needs a lot of muscle to be able to do that. Keep in mind that our circulatory system is comprised of thousands and thousands of miles of blood vessels. So it's also a very efficient circulatory system. So in this proportion of the population, the left ventricle is completely hypertrophic or non-functioning, in some cases is completely dysfunctional. And therefore, well, a person cannot survive without left ventricle because there will be no oxygen going to any cell in your body. The only reason why babies survive for a couple of days is because there is a connection called the patent ductus arteriosus that connects the pulmonary circulation, this blue one, with the systemic circulation through the aorta. So we have a natural bypass when we're born that actually mixes the two circulations. So this is able to keep somebody or a baby alive for about 3 days without a left ventricle. But unfortunately, that ductus closes in about 5 days on its own. So the doctors have to intervene and either keep it open or insert a shunt somewhere where you can actually provide blood to the systemic circulation and hope that the only functional ventricle, which is the right one, is actually strong enough to be able to supply blood everywhere. And that the blood gets oxygenated enough so that the oxygen saturation is not is high enough to be able to keep the person alive. So that's what this is a lethal condition. Babies 40 years ago would not be able to survive with these, but thanks to the innovation of a few surgeons over the years, they have been able to correct this condition, and they have been able to nowadays achieve survivability upwards of 50%. So more than half the babies that are born, who are born with these conditions, are able to survive. So there's 3 procedures, and Dr. Kassab is going to talk about the modeling, how we as engineers contribute to this. I think this is all, obviously the doctor plays the main role here, and patching things up and installing or implanting these shunts and bypasses to be able to keep the person alive. But we can do preoperative modeling. We can go to the computer, apply the equations of fluid mechanics, make sure that the model is set up properly, and then we can calculate the things that we think are the parameters that are going to keep the baby alive. The right pressures, the right flows, et cetera, et cetera. And once we are confident that that's the case, we test it on this, we write our simulation code to be able to test this in silico, it's called, computationally. Then we test it also experimentally. So we have an experimental rig, what we call a mock flow loop, where we can test this and then cross-validate with a numerical solution. Once we cross-validate these 2 things, then that gives a certain level of confidence that the doctor can use as, okay, then I can actually do this, implant this bypass or the shunt at this location, at this particular angle, at this particular length, or with this particular diameter, so that I can accomplish the parameters and the numbers that are going to keep this baby alive long enough so that I can come back 6 months later and intervene with a second operation. The first of these operations is called the Norwood operation. Again, it happens within 3 days of birth. And there's some details of these operations that Dr. Kassab is going to talk about, where, for example, as you can see, the only functioning ventricle is used to supply blood to the systemic circulation and the pulmonary circulation. A shunt is installed so that the 2 circulations actually remain connected even after the ductus arteriosus closes. And then hopefully this mixture of oxygenated and deoxygenated blood produces enough oxygen saturation to keep the person alive. Not only oxygen saturation, but the cardiac output is enough and the pressures are good enough and so on. There's a second operation that occurs about 6 months later. It's called the bidirectional Glenn procedure. And Glenn, what this procedure entails is basically disconnected the return from the inferior circulation, from the inferior vena cava, disconnecting it from the pulmonary circulation and sending it back, or the upper circulation, basically connecting it directly to the pulmonary circulation. So the superior return, the return from the superior circulation from the head and the arms is connected directly to the pulmonary arteries and is not passed to the heart. So basically it flows to the lungs by inertia. And there's a lot of problems with these, obviously, which I'm not going to go into details. But this operation is obviously very intrusive, a lot of things going on, a lot of disconnections and connections. The babies, these operations can take 10 hours. The babies are connected to a lung heart machine to keep them alive, and the success rate is quite high for its complexity. Then the third operation is called the Fontan-Kreutzer procedure. This is 2 physicians simultaneously came up with these procedures back in the 70s. Francis Fontan in France and Louis Kreutzer in Argentina. They both developed this procedure independently and simultaneously. For some reason, it's commonly known as a Fontan procedure, but the credit should be Fontan-Kreutzer. It takes place nearly between 1 and 3 years of age, and this is a full disconnection of the return. Basically, take the superior vena cava, the full return from the upper circulation, the inferior vena cava, which is the full return from the lower circulation, with all the deoxygenated blood that has traversed your body, and then connect them directly to the pulmonary artery so that it goes to the lungs for oxygenation, bypassing the heart altogether. So the hope is, can the blood come back from the body at a very, very tiny pressure of about 6 or 7 millimeters of mercury and have enough inertia to go to the lungs and be able to traverse all the 3 billion bronchi in the lungs and then accomplish oxygen exchange and CO2 exchange in the membranes. So this has complications associated with elevated pressures and so on. And Dr. Kasab's going to talk about this in a couple of days. How do we model this, and how do we go about ensuring that this pressure is not, there's not a buildup of pressure close to some of the vital organs that are not going to produce liver failure or kidney failure and so on. So those are the comorbidities associated with these procedures. So how do we go about this? And I'm going to briefly talk about the phase 2 hybrid, which is something that Dr. DeCampley has put together, an idea that he has put together as to how to make this particular operation, the second phase, the Glenn phase, how to make it either for a subset of patients that satisfy certain parameters, how to make it less intrusive, and how to make it so that we can bypass the last operation. Obviously, as a parent, you don't want to go through any surgical procedure for your kids, but if you can eliminate 1 or 3, that would be terrific. So he has come up with this idea called the hybrid comprehensive stage 2, or the fase 2 híbrida, where he, despite positive outcomes from the comprehensive stage 2, the conventional palliation has been documented to have significant mortality, again, more than 50% or close to 50%. So pioneered at Arnold Palmer Hospital, the hybrid comprehensive stage 2 is designed to be applicable to a subset of patients. Not all of them qualify for these. It reduces trauma from the second stage and retains the ventricular septal defect, so a connection between the 2 ventricles. So these are actually hand sketches from Dr. DeCampley that made it to the literature. He designed this himself. And how do you go about an incision is made in the right pulmonary artery at the proposed superior vena cava connection. A guide wire and a stent catheter is inserted through the RPA, and then the stent is deployed. Finally, the homograph baffle is sewn from left to right pulmonary artery orifice. The third stage is the baffle is sutured and is trimmed to fit around the stent. The stent is then sutured to prevent migration. And finally, the incision is closed and both the heart and the vasculature is de-aired. Finally, the cava pulmonary anastomosis is performed. So keep in mind that this is a baby, so this is tiny. So the person who's performing this procedure has to have artist hands to be able to accomplish this and to do it correctly and prevent any obstructions and ensure that the circulation is accomplished. So here are some angiographic images of these after the procedure. So these procedures have already been made. And because of these are life-saving procedures, the doctors can bypass a lot of the regulations, the FDA, the Food and Drug Administration regulations for performing surgical procedures. So they have certain liberties or leverage into performing these type of things. So we come up with what we call an in silico generic geometry. So we create a generic geometry on the computer that is not patient-specific, that it has the generic dimensions of the anatomy of a baby of that age with the location of the different vessels. And this is what we call the area of interest, the centerpiece, basically where the things are happening are of interest to us. But you cannot model this in isolation, right? Because the circulatory system is a self-enclosed system. There's a connection, an outlet ends up in an inlet. So you have to reconnect all these vessels back to the inlets, all the vessels in the outlet back to the inlet. You cannot model this computationally using computational fluid dynamics because then it will be too prohibitive for any computer system in the world. Again, we're talking about thousands and thousands of blood vessels and thousands of miles of blood vessels. There's not enough computational power in the entire world to be able to mesh this geometry and let alone actually run it in a CFD code. So what we do is we, at some point, after the area of interest, we make some compromises and say, okay, past this point, the behavior of the blood flow is quasi-linear, and then we're going to model the blood flow with these hydraulic analogies using electric circuits, and then we're going to connect all these electric circuits to everything, and we're going to use analogies that say, well, the friction of the blood in a vessel is akin to what a resistor does in an electric system, The inertia of the blood flow in a vessel is akin to what an inductor does in an electric circuit. The compliance of a vessel, the fact that a vessel distends and contracts, is akin to what a capacitor does in an electric system. And finally, the open and closing of a valve in the heart, the aortic valve, the mitral valve, the pulmonary valve, or any of these valves, is akin to what a diode does in an electric circuit. And we put all these things together and create this massive circuits that dozens of degrees of freedom, and connect them to formally interface with the computational fluid dynamics that occurs at the centerpiece. So this is in a nutshell how these systems go, and we call these multi-scale modeling. Why multi-scale? Because what happens in the centerpiece is fully three-dimensional and transient. It's four-dimensional essentially. But what happens in the circuits is zero-dimensional and transient. So we're connecting zero-dimensional models to three-dimensional models and coupling them after every time step, every discretized time step. So there's some details about how to model certain things, like in the CFD, we have to assume that the blood is a non-Newtonian fluid and use some special models to be able to accommodate this. Numerically, we talk about, well, what happens also, these procedures, because the doctors alter the anatomy and the physiology of the circulation, they create certain unnatural behaviors of the fluid flow. And when the flow does things that it's not supposed to do, like recirculate or impinge directly into a wall, then the blood thinks that something's happened, and it has a tendency to coagulate. And when it coagulates, it forms a blood clot. And then when a blood clot is formed, it has the potential to travel to the brain and kill the person by a stroke. So we have to worry about these things too. Obviously, the patients that undergo this procedure go into very heavy anticoagulant therapy. And then, so we have to model what happens if a particle is formed, where is it gonna go, where's it gonna stay, is it gonna go to the brain, and try to minimize its probability. So we have to worry about all these things. So we do what we call Eulerian Lagrangian CFD modeling, where we take the fluid domain and introduce particles that are attracted by the laws of Newton, basically. We also have to worry about, in this hybrid phase, the doctor introduces a stent to keep things open in the area of interest. And we have to worry about the stent deformation. So we have to model the elasticity of the stent, and we have to know, and we have to do some fatigue analysis to make sure it's not going to fail after so many heartbeats. These are, again, some angiographic images that we use to create our own centerpieces for the cross-validation of these computational models in the experimental realm. So we do, again, cross-validation between computational and experimental models. Once both agree, then we have the confidence that it's supposed to be correct. Okay, so we fabricate these centerpieces using translucent materials to be able to track particles and to see the flow behavior. We have a particle image velocimetry system where we can track the flow and use it to actually recognize local hemodynamic and verify that as well, validate. I'm going to go through these things. We also have a facility at our university where we can do scanning electron microscopy. So we can actually look at the microscopic structure of the stent, evaluate things that could happen as micro cracks, and make sure that it's not going to lead to failure of the stent. This is some pictures of our flow loops. These has actually evolved into something a lot more comprehensive than this. There's some pictures of the lump parameter model that we use in the experimental setup. We have a higher reduced order of the cardiovascular system, also simulated through electrical analogy. We also do image processing, use some Kalman filtering and machine learning algorithms to be able to track the deformation in situ of the stent and of the baffle and of all the things that occur in this. And then we use image processing and codes that are developed in-house to be able to track the deformation of these. We also track the oxygen saturation throughout the circulation. And oxygen saturation has been something now that is in kind of common knowledge now because of the pandemic. We know what oxygen saturation is. Pretty much all of us have oximeters now, and we want to keep oxygen saturation above 95%, right, to make sure that we are alive. And we can track this numerically. We have a numerical model for these. We also have an experimental model to predict oxygen saturation. And in these babies, we want to keep that oxygen saturation as close as possible to 90%. Because remember, there's a single ventricle. The dirty blood or deoxygenated blood is being mixed with deoxygenated blood, so we're actually sending blood to the circulation that is not at 100% saturation. And want to make sure that we keep track of that at every location. And it's always at least close to 90% to keep the person alive. So we have some results. How much time do I have? Am I still okay? Okay. So we have some results of, again, this is multi-scale CFD. What you see here is some streamlines of the pulsating flow, transient computational fluid dynamics, full 3D. But again, these results are coupled with, or what you're seeing here, the outcome of the coupling of the 3D circulation with the 0D peripheral circulation. So this is results of multi-scale analysis. Here you can see, and you can see on the left what portion of the of the cardiac cycle you're in, either peak systole or diastole, and what the flow lines do. So we are very interested too in the local hemodynamics, not just that we maintain the flow that we need, that we maintain the pressures that we need, that we maintain oxygen saturation. We're interested in the local hemodynamics because when the blood does something weird, the blood is prone to coagulation. And we want to be able to at least infer where that could happen or predict if we can actually do something to reduce the possibility that this can actually lead to a blood clot in the brain and kill the patient. So this is a result, again, is a fully coupled, now we're coupling the 3D CFD with the 0D lung parameter model of the peripheral circulation with the elastodynamics of the buffle. So we're solving Navier-Stokes equation, Navier equation, and the full set of electric circuits to try to see where the stress concentrations will be on the buffle and see if we can identify potential failure points and so on, or points of large deformation as well. Let's see if I can. Particle tracking, as I mentioned, well, let's assume that blood is going to coagulate at certain locations, and let's throw in thousands and thousands of particles that can potentially exist, and then let's statistically track and see what they're going to do. What is the average particle residence time? How long are they going to spend in the center of the circulation? Or is there a possibility that these particles are going to go to the brain somewhere? Is there a possibility that these particles will just go down the drain through the descending aorta and end up in a toe? It's okay to have a black toe for a week. It's not okay for a blood clot to end up in the brain. So these are the type of things that we try to model. And we do the stent deformation modeling, as I mentioned, the stent, the buffle inside, or the stent inside the buffle. And we basically compile all these results, compile all the statistics, look at the oxygen saturation, depending on the location in which, or depending on what we do, what is the resulting oxygen saturation at the different locations, okay? So you are shooting for something as close as possible to 90% to be able to keep the person alive. And you're shooting for very specific flow rates. I mean, if I go back, you're shooting for very specific flow rates for cardiac output, 2.94 liters per minute of cardiac output is basically what you can shoot for in a normal anatomy, in a normal heart on a 6-month-old baby. But 1.7 liters per minute is the minimum possible that the doctors actually dictate these guidelines for us and tell us, this is the minimum you can accomplish. This is the minimum oxygen saturation that I would allow. This is the minimum cardiac output that I will allow. This is the maximum pressure I can tolerate at this location. How can you accomplish that? And this is years and years and years of iterations, back and forth. Let's try to do this. And needless to say that every one of these models takes weeks to converge, because you are coupling 3-dimensional, fully transient pulsatile CFD with 0D lung parameter models and electrical circuit analogies, and then you're coupling this with the elastodynamics of the solid, of the structural modeling of what's going on inside, So these are very time-consuming and very, I would say, unstable-prone type of analysis. Also part of the image processing, and how do we track the deformation of a buffle through image, or the stent through image processing, and how these algorithms actually coincide with the truth. So in summary, this study provides insight on a novel palliative procedure for patients affected by congenital heart defects. Hemodynamics quantifications reveal no significant pathological flow patterns. In vitro and in silico results display a good degree of agreement for both oxygen transport and stent deformation. And the ongoing work on this is additional mock flow loop and computational stent deformation studies are being conducted, currently carrying out particle residence time estimations and mock flow loop to validate CFD observations. So this is a never-ending work. We keep adding complexity to the model, keep worrying about some different things, keep worrying about different cases, and again, every case is different. So, and our hope is that eventually we'll have a predictive tool that can be used as part of the preoperative planning for the surgeon. When we talk to Dr. DeCampli and he has a big case coming up, he has to have the peace of mind to know that what he's going to do is going to be correct and it's going to save the patient. And he tells us that before a surgery that can last 6 hours, the night before he rehearses it in his brain. And he actually closes his eyes and moves his hands and rehearses the entire procedure before it actually happens. So all of these has to be second nature before the procedure and before the outcome of the procedure takes place. Very exciting work, and again, something that gives us a lot of pleasure because we believe that it's making an impact, a direct impact in somebody's life. So thank you again for your hospitality, your great city, and the great organization. On behalf of Embry-Riddle Aeronautical University, the University of Central Florida, Arnold Palmer Hospital, and the two other organizing institutions, Escuela and UPN, or Universidad Politécnica del Norte and Escuela. We acknowledge also the support from different societies, associations, institutions, philanthropic organizations in the United States. The American Heart Association has sponsored a lot of our work. The Additional Ventures philanthropic organization has sponsored a lot of our work lately too. And more recently, the Children's Heart Foundation, CHF, has given us a grant to continue some of this work. And again, this is a preamble. I try to keep it as flyover as possible. It's a preamble of what Dr. Kassab is going to talk in his keynote lecture in Galapagos. He's going to go down into the details, mainly of the third operation, the final one, Fontan, to make sure, the Fontan-Kreuzer operation, to make sure that that's going to be the end goal, okay? The bridge to life for all these kids. So thank you again, and thank you.
Gracias, doctor, por su intervención, y efectivamente pues será esto un preámbulo de todo lo que vivirán en Galápagos. Él presentaba también al equipo de coordinadores y el equipo de expositores. Es por eso que también en esta mañana queremos, como un gesto de gratitud, entregar reconocimientos a quienes serán los expositores. Me permito llamar en primera instancia al doctor Víctor Hidalgo, para que por favor reciba de parte del señor decano, el doctor Ángel Ramírez, un reconocimiento. Cabe mencionar que estos reconocimientos son souvenirs de la marca Escuela, al igual que de la empresa pública municipal de turismo, promoción cívica y relaciones internacionales del municipio de Guayaquil. Así que vamos a, por favor, a recibir este primer reconocimiento a nuestro primer expositor, el doctor Víctor Hidalgo. Un aplauso, por favor. Queremos también invitar al doctor Alain Kassab, por favor que nos acompañe, doctor Alain, acá a recibir un reconocimiento. Queremos en esta instancia invitar al doctor Clotario Tapia, coordinador de este evento, para que entregue también este segundo reconocimiento. Muy bien, hacemos la entrega de los souvenirs marca Espol, también pues de Guayaquil, la ciudad de Guayaquil. Un aplauso para él. Gracias por estar aquí. Y también invitar al doctor Luis Carlos Gobel, el de la Universidad Pontífica Católica de Río de Janeiro, también que nos acompañe y que reciba de parte de las autoridades este reconocimiento. Demos también un fuerte aplauso a él. Gracias por acompañarnos en esta jornada de exposiciones. El siguiente expositor es el doctor Eric Saavedra, de la Universidad de Santiago de Chile. Aún no llega, ¿verdad? Pero igual él recibirá también sus souvenirs. Bueno, hoy les estamos dando la bienvenida a nuestro país, a nuestra casa, la ciudad de Guayaquil. Mañana partirán hacia Galápagos para continuar con la conferencia, pero hasta eso, con el apoyo de Espol Cultural, queremos mostrarle un poco de la cultura tradicional costeña. Vamos a dar un fuerte aplauso al talento, a las voces, al talento de Espol y apreciaremos un poco de nuestra cultura a través de la música y la danza. Bienvenidos.
La salsa que te han visto, no te han visto nada. Dicen que te han visto, la enaguana bordada. Dicen que te han visto, la enaguana bordada. De los dos que están bailando, si me dieran a escoger, yo como más inocente, escogiera a la mujer. Yo como más inocente, escogiera a la mujer. Dice,
ya salieron a bailar, la rosa con el clavel. Flores, el clavel la recoge, la rosa regando flores, el clavel la recoge. Ya salieron a bailar, la rosa con el clavel, la rosa regando flores, el clavel la recoge, la rosa regando flores, el clavel la recoge.
esta es la alegría del litoral ecuatoriano, con ballet folclórico y la rondalla del Espol. Bienvenidos a Ecuador. Del cielo cayó un pintor para pintar tu hermosura, y al ver tu cara tan linda se le cayó la pintura. Y al ver tu cara tan linda se le cayó la pintura. El montubio es cara dura, la montubia primorosa. Si tú me dieras una rosa, yo te daría mi ternura. Si me dieras una rosa, yo te daría mi ternura. Sí.
Ya salieron a bailar, la rosa con el clavel, la rosa regando flores, el clavel la recoge, la rosa regando flores, el clavel la recoge. Ya salieron a bailar, la rosa con el clavel, la rosa regando flores, el clavel la recoge, la rosa regando flores, el clavel la recoge.
Con fuerza, compadre, señor. Ballet folclórico y rondalla del Espol. saber, señores, la virtud de las iguanas.
La virtud de las iguanas.
Pues se suben por el tronco y se bajan por las ramas.
Y se baja por las ramas.
Las benditas iguanas se han comido mi cabal y ahora tengo el trabajo de volverlo a resembrar.
De volverlo a resembrar.
Si quieres comer iguana, ¿por qué no me lo dijiste?
¿Por qué no me lo dijiste?
En mi casa tenías una, ¿por qué no te la comiste?
¿Por qué no te la comiste?
Si quieres comer iguana, vámonos al platanal, que con los rayos del sol se sale a calentar.
Se salen a calentar.
Desde Guayaquil para todo el mundo, ballet folclórico y rondalla de la Escuela.
¡Sí, señor! Muchas gracias.
De Spol Cultural por demostrarnos el talento y este es como una vitrina exponiendo la cultura costeña de Ecuador. Ahora quiero invitar al doctor Diego Ortiz, él es coordinador académico de la Universidad Tecnológica del Norte, quien va a hacer la entrega de reconocimientos al equipo coordinador de este congreso. Así que lo invito por favor, doctor, para que sea usted quien los llame y se cumpla con la entrega de estos reconocimientos. Bienvenido.
Un gusto estar aquí en la SPOL, saludarles a cada uno de ustedes a nombre de nuestras autoridades de la Universidad Técnica del Norte, doctor Marcelo Ceballos, rector, y actualmente electo el doctor Miguel Naranjo Toro. Realmente ha sido un año muy importante donde las amistades surgieron con ideas para unir la ciencia, para unirnos a través del conocimiento y construir un sueño. Realmente un agradecimiento a Eduardo, a Víctor por esas iniciativas que conjugaron a través de Clotario y David, al cual tuve la oportunidad de vincularme y estar con ustedes trabajando para que en lo posible que este grupo de amigos podamos seguir trabajando en unidad con otros países. Esperemos de que ese sueño en este día pueda surgirse. Entonces, a nombre de la Universidad Técnica del Norte quiero hacer la entrega de ese reconocimiento. Como Ecuador y a través de sus diferentes ciudades, tiene una fe en un Dios o en algo, que permitió a través de las diferentes historias construir sus ciudades. Así como el día de ayer veíamos un poco de historia y que a través de las diferentes batallas se lograron las libertades. Así también tenemos en las ciudades de esa fe que ayudó a construir y fomentar una ciudad. Nosotros en la provincia, en la ciudad de Ibarra, tenemos la fe a un ángel que se llama San Miguel Arcángel, que significa una persona que a través de su espada liberó del mal a la ciudad. Entonces, eso siempre cuando tú entras a la ciudad está su magnífica imagen de recibimiento. Eso queremos hacer la entrega y Eduardo, si me permites, que pases, por favor. Es un arte que tenemos nosotros en un lugar de San Antonio, en donde lo hacen en madera y sus diferentes réplicas, obviamente con la tecnología, pero principalmente es el arte en la madera. A nuestro segundo gran amigo y el que siempre les teníamos molestando a cada instante en las reuniones, a Víctor H., como llegamos a decirle. Víctor, por favor, si nos acompañas. Víctor H. Vaya nave. Y también pues al compañero que siempre nos abrió las puertas, y este es del premio sorpresa, como le decía, Clotario, por favor, si nos acompañas, por señal de esa amistad que fuimos construyendo en este tiempo. Muchas gracias a David también. Luego también hay un poco más de historia que se unió también con su página Víctor Hugo Hidalgo. Entonces quedamos del compromiso y conversemos durante el trayecto de esta mañana y tarde y noche para ver si logramos concluir ese sueño. Y aquí tenemos dos grandes líderes para ver si lo hacemos la Sociedad Panamericana. Generamos ya en este día con la firma de un acta y su nueva directiva. Eso estaremos trabajando en estos instantes. Muchas gracias a todos.
Para culminar con esta inauguración, los invitamos cordialmente a acompañarnos en el lobby del edificio, en donde seguiremos disfrutando del talento con un show cultural de danza y música, y luego los invitamos a degustar comida típica guayaquileña. Gracias a todos por estar aquí y que les vaya muy bien en su congreso y en su viaje hacia Galápagos. Buen día a todos.